The first thing we're going to look at is the difference between the word verify and the word prove. They are very similar. A verify question just says you're checking one answer, but you set it up the same as a prove. So if I have for part A a verify question, I would plug in the 30 degrees, draw my straight line, and just like a proof, I need my left side to equal my right side. But I'm only checking it with 30 degrees. So, cos of 30 degrees is on your unit circle. What is cos of 30 degrees? Let's do that one first. 1 plus, root 3 over 2 or 1/2? Root 3 over 2. So if that's true, then secant of 30 degrees would be 2 over root 3. And on this side, I'd have 1 plus 2 over root 3. And now we have to do algebra to see if these are the same. So what might I do? Well, maybe I would distribute this. And I would get 2 over root 3 and multiply the tops, multiply the bottoms. Might notice, hey, those are exactly identical. So this will be 2 over root 3 plus 1. My left side and my right side are the same. And you're done. So verify question, plug in the number, and see if they're the same. Verifying just shows one number works. A proof is way more powerful. In fact, if you prove something, you've technically verified it for everything. So proof is way more powerful. So for this one, the question is, could you prove it? So now I'll keep it with, was it theta or was it x? It was theta. So what's our main strategy? I'm going to go through our main strategy for this one and work it through all the way to the end. Our main strategy is you can change everything to sine and cosine. So in this case, I could change my secant to 1 over cos theta. And now on this side, I could change my secant to 1 over cos theta. Then, after changing everything to sine and cosine, the next part of the main strategy is to write both sides as one fraction. Technically, what do I have here? This would all be over 1, right? How do you multiply fractions? You multiply the tops, you multiply the bottoms. As a single fraction, does the left hand make sense that it would equal this? Multiply the top by 1, so it would stay the same. I multiply cos theta by 1 on the bottom. That's a single fraction. How do you add fractions? You would need a common denominator, right? This one right now is over 1. Are these a common denominator? No. I'm going to show you a common mistake. I'm going to do an E3 mistake right now. Okay, I want the same denominator, so I need a cos here and a cos here. And I would get common denominator cos theta, so now I can add the tops, which will be cos theta plus 1. Does anybody see my E3 error? What did I do to make me lose a half a mark? I got my common denominator. I multiply the bottom and the top to get a common denominator. I got it there. What did I miss? Can you see yourself doing this? Seems good, right? Okay. I purposely acted like a student, right? We like to do things quick. I forgot a theta here. This one was messy. Doesn't have the line across. They would accept that. But forgetting a theta once will cause an E3 error. Cos by itself doesn't mean anything, right? You're like, what's the big deal? Well, then I'll start calling you by your name and I'll take out a letter. I'll just randomly take a letter out of your name and see if you like it. Ma. Right? Instead of Max, just take out the X. Call Ma from now on. That'd be a little bit awkward, right? The theta is very important because a trig function doesn't make sense without the angle. You have to, at any point in a proof, after they mark the proof, they look at your whole proof and say, did you forget a theta anywhere? Even if off on the exam, if off in the corner, you made yourself a little note. If you did this off top right-hand corner, very far away from the question, they'd be like, oh, look, they forgot the thetas. Take off an E3. Right? So be careful, even if you do it off to the side, even if you're doing it quickly, take your time, write things out, don't try to skip steps. It's not worth it. So now, the two sides are the same, so we can write left side equals right side. U, E, G. So for the second one, I'm just going to prove it. I'm not, verifying's actually a little bit annoying. Because once you've proven it, you don't have to verify anything. You just like, I proved it for everything. Of course it works. So proving is way more powerful. But verifying is like combining a unit circle question with a proof. Okay? For chapter 7, when we do our chapter 7 test, you will be able to use your pie plate. So any verify questions or and you will have questions you'll need pie plate values. You don't have to have it memorized in the moment. You can use your pie plate for that. Okay, so if we want to prove this one, let's see, do I have it set up? Nice. I have it set up to do it two different ways. Because we're going to start developing some more proof strategies. We're going to start this one with the normal basic strategy. You can change everything to sine and cosine. Okay? So I can change tan to sine theta over cos theta. I can change cotangent to cos theta over sine theta. Then after you've changed everything to sine and cosine, now you want a single fraction. Now it's all fraction work. Can you get a single fraction on both sides? Well, on the left side, I have technically a fraction minus a fraction. How do I add and subtract fractions? I need a common denominator, so I have to multiply this by cos theta and this by cos theta to get that common denominator. And I would get common denominator of cos theta, and the top would be cos theta minus sine theta. Single fraction on the left. On the right-hand side, I have fractions inside of fractions. The exam will love to make you work with fractions inside of fractions. So what do we do when we have fractions inside of fractions? We get a single fraction on the top and a single fraction on the bottom. And then when you have a fraction divided by a fraction, the rule is multiply by the reciprocal. So Do I have a single fraction on the top? Not yet. This is 1/1. So in order to combine this, I need a common denominator. So I multiply top and bottom by sine of theta to get a common denominator. So now I would have, sometimes I make my main fraction line like extra thick and extra long. Because on the top I have a fraction, it's going to be a sine theta on the bottom. And now that I have a common denominator, subtract the top. On the bottom, I still have cos theta over sine theta. One thing to make sure you do in a proof, and a couple of just recommendations. It can get very busy because you have fractions inside of fractions. I hope you notice I tried to right here leave some space. So I didn't get confused with where the top ended and the bottom started. Okay? Second, I make sure that what I write here has to equal what I write next. I never just do work on the top and forget to write the bottom. You're going to be tempted to do that. You're like, oh, I don't have any work to do on the bottom. I'll just do the work on the top and not rewrite the bottom. They'll always take off marks for that. Every time they check, they say, is the next line that you wrote equal to the line above it? If something's missing, even if you add it later, you will get marks taken off for that because it has to always equal what you had above. So again, now I have a fraction divided by a fraction. I'm going to leave some space here, but I can multiply by the reciprocal. So the top one would stay the same. Multiply by, flip the bottom. Now, when you're multiplying fractions, you can simplify if you have an identical factor on the top and the bottom. And factors are joined with adding and subtracting. So I'm going to add brackets to this one. This has to stay together. I cannot cancel this sign with this sign. I cannot cancel this cos with this cos, because this is one full factor, and the only way you could simplify it is if you had the exact identical thing on the bottom. But once that's grouped together, do you notice that these are identical? So those could simplify and go away. If they did, how do you multiply fractions? Well, what am I left with? On the top, I'm left with cos theta minus sine theta, and on the bottom, I'm left with cos theta. For 90% of proofs, if you change to sine and cosine and get a single fraction on both sides, and then look, how am I doing? Hey, they're the same. They're going to be the same 90% of the time. We're going to get to some advanced ones where we have to do some extra things. But for this one, look at that, we're the same, so we can make our statement that the left side's equal to the right side. And we're all done. So see this whole thing. So notice again, you see how I left some space in between there. I left like space in between, sort of keep it nice and neat. This section is equal to this section is equal to this section. Here I left space again, is equal to that section. Don't skip things. Show extra work, show all of your steps along the way. Otherwise, marks are very easy to lose in proofs. Okay, now, I did this with the main strategy, and I will tell you in this one, it is not the best strategy. There are other strategies as well. Like, for example, is there a way you can change tangent to cotangent? And cotangent to tangent? This one only has tangent and cotangent, so I might go about this one and say This would be a lot easier if I change things either to tangent or to cotangent. In fact, I think this one's easiest if you change to cotangent. Because if I change to tangent, you see on the right, this would be 1 over tangent, 1 over tangent. I'd have still fractions inside of fractions. Not hard, but I'd have to do that work. If I change to cotangent, that would be 1 minus cotangent. Can I get a single fraction? Absolutely. What would my common denominator be? Cotangent, cotangent. And, well, look how short that is. That's a lot quicker, right? So sometimes proofs can be, the main strategy is good, it will work, but it may make your proof longer. If you can get both sides of your equation with the same trig function in one step, that often can be shorter. And in this case, you can see how much shorter it is if I change everything to cotangent. So proofs give you some options. No options are wrong. Some options are faster than others. Okay, so sometimes when I finish a proof, I'm like, oh, that seemed a little bit long. I look at it again and say, is there anything I could have done differently to make it faster? That's a good strategy to do when practicing, because then you'll see sometimes shortcuts. All right, so questions you can circle for number 1 are 3, 5, 6, and 7. I'm going to go I, because I says verify, and you can do it if you like, but this saves you some time. You don't have to do the verify part.